Pluto, that small, icy world hanging out on the far edge of our solar system, has always captured our imagination. Once proudly called the ninth planet, it was later downgraded to a dwarf planet, but that hasn't kept it out of the spotlight. Now it's making headlines again thanks to big names like Neil deGrasse Tyson and Michio Kaku. They're stirring up an incredible theory: could Pluto actually be on a collision course with Neptune? It sounds wild, but they're not just throwing out random ideas. They're suggesting that the path Pluto follows could eventually lead to a crash with one of the solar system's giants. This idea raises a lot of questions. How could such a collision even happen? What would it mean for the solar system? And is this just a far-off possibility or something we need to take seriously? Pluto's orbit around the Sun comes uncomfortably close to Neptune's, and that's the reason Tyson and Kaku are concerned. If even a slight change happens in Pluto's path, we could be staring down a massive cosmic fender bender. Could this chain reaction even put Earth at risk someday? The thought alone is enough to make you wonder how delicate the balance of our solar system really is. When you take a closer look at Pluto, you realize how unusual it truly is. Even though it's been kicked out of the Planet Club, Pluto continues to fascinate scientists. What Tyson and Kaku are pointing out is that Pluto's orbit is much closer to Neptune's than we usually think. They're ringing alarm bells because if anything disturbs the current setup, we could see major consequences. Pluto's journey around the Sun is completely different from the paths taken by other planets. It takes Pluto about 248 Earth years just to complete one orbit, and even now, since its discovery in 1930, it still hasn't finished a full lap. But the weirdness doesn't stop there. Pluto's orbit isn't neat and round like most planets. Instead, it's wildly stretched out, making it far more elliptical. Plus, it's tilted at a sharp 17-degree angle compared to the flat plane where most of the other planets travel. These two things, the stretched shape and steep tilt, make Pluto's path truly one of a kind. What's even crazier is that for about 20 years during its orbit, Pluto is actually closer to the Sun than Neptune is. You might wonder, with paths that close, why haven't they already collided? Well, it all comes down to some mind-blowing gravitational mechanics. Scientists started investigating Pluto's strange orbit almost immediately after discovering it. The big mystery was why Pluto behaved so differently compared to other planets. Most planets orbit the Sun in a relatively flat, smooth path, but Pluto's sharp angle and oddly shaped orbit made it an outlier. And the fact that it crosses Neptune's path just added another layer of confusion. Yet, despite all these oddities, Pluto's orbit stays stable, showcasing how precisely the laws of physics hold everything together. Imagine a cosmic dance where Pluto, Neptune, and the Sun are all pulling on each other through gravity, each movement carefully choreographed to prevent disaster. One of the key reasons Pluto hasn't crashed into Neptune is because they're locked into a delicate cosmic rhythm. Every time Pluto crosses Neptune's orbit, it's always at least 90 degrees away from Neptune itself. This precise timing is critical and acts like a cosmic safety net, ensuring they never meet head-on. Another clever trick of nature is that Pluto moves above and below the plane of Neptune's orbit. So even when it's closest to Neptune, Pluto is physically higher up in space, giving them even more distance to avoid a catastrophic collision. It's a brilliant setup that keeps both worlds safe. There's also something fascinating known as the VZK wobble, named after three scientists who studied how gravitational forces affect the motion of objects in space. This wobble explains why Pluto's orbit behaves so strangely near the Sun. Even though Pluto's path seems chaotic, this wobble actually stabilizes it, ensuring Pluto doesn't go spiraling off into deep space or smashing into Neptune. Understanding this three-body relationship, Pluto, Neptune, and the Sun, is crucial because it reveals how gravity subtly controls the motion of celestial bodies. It's like an intricate, invisible web holding everything in place. Back in the 1980s, computer simulations shed more light on Pluto's behavior. These early models showed that while Pluto's orbit looks pretty stable, it's actually highly sensitive to tiny changes. Even a slight shift at the beginning could lead to massive differences over millions of years. However, the good news was that despite this sensitivity, Pluto's orbit had remained balanced for billions of years. Later research confirmed that the massive gravitational influences of Neptune, Jupiter, and Saturn all play a part in maintaining Pluto's stability. Without these giants acting as cosmic bodyguards, Pluto's path might have been much more chaotic. It turns out that Neptune and Pluto have a particularly special relationship. For every 3 orbits Neptune makes around the Sun, Pluto completes exactly 2. This 3:2 resonance is a stabilizing force that helps prevent collisions. But Neptune isn't doing the job alone. Jupiter, with its enormous gravitational pull, provides additional balance, and Saturn chips in as well. Scientists believe Jupiter's influence is especially crucial because it acts like a giant gravitational anchor, helping to keep Pluto's orbit from spiraling out of control. It's like an entire cosmic team working together behind the scenes to keep the solar system running smoothly. Without these gravitational partnerships, the solar system would be far more chaotic. Planets could crash into each other, get thrown out into deep space, or be pulled into the sun. Understanding how Pluto's orbit is maintained helps us appreciate the delicate balance that keeps everything in order. It's a reminder that space is not as empty or random as it sometimes seems. Every motion, every orbit, is part of a carefully orchestrated system that has been operating for billions of years. And studying Pluto helps us better understand not just our own solar system, but how planetary systems everywhere might behave. Even though Pluto's orbit looks wobbly and strange, it's actually a perfect example of how balance can be found in chaos. Thanks to gravity, even something that seems unstable can maintain a steady course over an incredibly long time. Watching these distant, quirky worlds teaches us valuable lessons about our own place in the universe. It reminds us that the cosmos is full of surprises, and sometimes, the weirdest objects can tell us the most about how everything fits together. Pluto's story is far from over, and what we learn from it could help us unlock even bigger mysteries of space. Now, when it comes to why scientists like Tyson and Kaku are sounding the alarm, it's all about those tiny changes. Pluto's orbit shows that even the slightest adjustment to its position or speed could send it on a completely different course. Scientists have used complex computer models to simulate Pluto's behavior, plugging in different starting conditions to see what would happen. These simulations show that slight changes can snowball over time, making Pluto's future path very hard to predict. It's like setting a marble on a table, move it just a little and it could roll in a completely different direction. Back in the 1980s, when computer models first started exploring Pluto's future, researchers found something surprising. Even though Pluto's orbit looks a little messy, it has key features that keep it stable over time. Still, if you tinker with the starting details even slightly, the final result could be drastically different. That means Pluto's future isn't locked in stone. It's stable, yes, but also precarious. Predicting orbits like Pluto's is one of the hardest challenges in astronomy. The tiniest errors or unknowns can have enormous effects, making it difficult to say for sure what might happen millions of years from now. These computer simulations have taught scientists a lot about how orbits behave. They're powerful tools for helping us guess what might happen in space, but they also reveal how much we still don't know. When the starting conditions change even a little, the whole future changes too. That's why people like Tyson and Kaku are raising concerns now. They're pointing out that while Pluto's orbit seems stable for now, there's always the potential for unexpected changes in the distant future. And when two cosmic bodies like Pluto and Neptune are involved, even a tiny mistake could eventually lead to something big. Neil deGrasse Tyson, a well-known scientist and someone who's always passionate about making space interesting for everyone, has a very unique take on these mysteries, especially the ongoing story of Pluto. Tyson, who famously played a role in Pluto being reclassified as a dwarf planet, offers smart insights into why the rules of space keep changing and why we stay so fascinated with the far reaches of our solar system. According to him, Pluto's new label wasn't meant as an insult but was simply a reflection of how our knowledge keeps growing. Tyson sees it as a step forward, a way to better organize our understanding of the neighborhood we live in around the sun. To him, Pluto's strange and complex orbit is not a problem but a reminder that the universe is far more complicated and thrilling than we sometimes realize. It's puzzles like these, he says, that keep the field of astronomy alive and exciting, always full of new mysteries waiting to be solved. But even though Tyson stays optimistic about discovery, he isn't exactly cheerful about the idea of Pluto crashing into Neptune one day. He expresses concern over Pluto's future because he understands how delicate and unpredictable orbital paths can be over long periods. Tyson points out that even though Pluto and Neptune have managed to avoid disaster up until now, slight changes, no matter how small, could eventually tip the balance. He highlights that Pluto's orbit, especially the part where it crosses Neptune's path, is an intricate and risky dance that might not always stay perfectly timed. If even tiny disturbances begin to build up over thousands or even millions of years, they could cause real chaos, potentially leading to a catastrophic collision. Thankfully, Tyson reassures us that such an event is unimaginably far away, way beyond any time frame humans need to worry about. Still, his concerns highlight the importance of continuing to monitor and study Pluto's journey through space very carefully. Tyson isn't alone in his concerns. Another brilliant mind, physicist Michio Kaku, shares a similar worry about the fragile balance of the planets. Like Tyson, Kaku is fascinated by the universe, but he's also very aware that the seemingly stable orbits of planets can actually be very vulnerable. Over long stretches of time, unexpected and wild events can completely change the dance of celestial bodies. Both Tyson and Kaku strongly believe that the only way to truly understand and possibly anticipate these changes is by pushing forward with space exploration and studying the invisible forces that quietly control the planet's paths and the future of our solar family. To really grasp why some scientists are getting concerned about a potential Pluto-Neptune collision, you have to look at the nature of orbits and space behavior over enormous timescales. In the endless expanse of the universe, even the tiniest shifts in an object's path can have a snowball effect, leading to massive consequences far down the line. Because Pluto's orbit is so weird and tilted compared to the rest of the planets, it's particularly sensitive. A small alteration here or there could spiral into something much bigger over millions of years. One reason the idea of Pluto and Neptune crashing sounds so unbelievable is because, despite Pluto's orbit actually crossing Neptune's, they've never collided. And that's not just luck. It's because of a fascinating cosmic rule called orbital resonance. In simple terms, for every 2 times Pluto goes around the Sun, Neptune completes 3 full orbits. This exact rhythm keeps them in perfect timing, ensuring that their paths never overlap at the same point. It's like a perfectly choreographed dance where the dancers never bump into each other, no matter how complicated the steps. This orbital resonance acts as a natural safeguard, silently protecting both planets. However, the concern from scientists like Tyson and Kaku comes from the knowledge that nothing stays exactly the same forever. Over millions or billions of years, slight changes could creep in. These changes could come from many sources, maybe the gravitational tug from another planet, or perhaps a rogue object passing by far away. Even a tiny nudge could slowly pull Pluto's orbit out of perfect sync. Gravity is reliable, but it's not immune to chaotic dynamics, a scientific term that describes systems where a small change at the beginning can lead to wildly different outcomes much later. In a chaotic system like the solar system, a tiny push today could mean a giant shift in the distant future. For example, imagine if Jupiter's massive gravity, even from far away, slightly tweaked Pluto's orbit. Over millions of years, that small difference could stretch Pluto's path just enough to break the resonance with Neptune. If that happens, the two could someday find themselves on a dangerous collision course. Scientists know it's extremely unlikely in the near term, but over the immense lifespan of the solar system, it's a real possibility that can't be entirely dismissed. And if Pluto and Neptune did collide, it wouldn't just be a dramatic event for those 2 icy worlds. The consequences could ripple outward, disturbing the fragile balance of the Kuiper Belt, the vast region beyond Neptune that's filled with countless small icy bodies. These disruptions could set off chain reactions, sending objects careening toward the inner solar system or out into deep space. Even though it's a remote possibility, it's enough to make astronomers pay very close attention. Realistically, the odds of a Pluto-Neptune collision happening anytime in the next few million years are astronomically low. It's more of a fascinating cosmic what-if scenario than an immediate concern. Still, scientists like Tyson and Kaku use it as a way to illustrate how delicate the solar system's balance really is. Their concerns aren't just about Pluto and Neptune. They reflect a bigger reality about how everything in space is interconnected, and how understanding these distant objects is crucial to predicting the solar system's future. Part of the reason we're able to explore these possibilities today is thanks to the powerful computer simulation scientists have developed. Using these advanced models, astronomers can simulate different future scenarios by adjusting conditions and seeing how orbits might evolve. These tools are incredible, but they also have limits because they can only be based on the information we currently know. And when it comes to the Kuiper Belt and beyond, there's still a lot we don't know. New discoveries could always change the picture. Finding another massive object out past Pluto, or detecting the gravitational influence of a hidden planet or even a rogue black hole passing nearby, could suddenly rewrite everything we thought we understood about Pluto's path. That's why space science is such a moving target. Every new piece of information means updating models, rethinking possibilities, and sometimes realizing that what seemed impossible might actually be more plausible than we assumed. Missions like NASA's New Horizons, which famously gave us the first close-up look at Pluto in 2015, are a big part of how we fill in these knowledge gaps. The more we send probes into the deep reaches of the solar system, the better we understand how these distant worlds behave. New Horizons taught us that Pluto is not just a frozen rock. It's a complex world with mountains, glaciers, and maybe even an underground ocean. Understanding its detailed makeup also helps scientists better predict how Pluto would behave in extreme situations, like a possible orbital shift. While the scenario of Pluto and Neptune colliding may seem like pure science fiction, it serves a deeper purpose. It reminds us that the universe is an incredibly dynamic and unpredictable place. Even when we think we've figured out the rules, nature has a way of surprising us. Many of the big processes that govern planetary movements are understood pretty well today, but the small details, the hidden influences, and the subtle shifts are where the biggest surprises often lurk. At the end of the day, the story of Pluto, its orbit, and the distant dance with Neptune is a powerful reminder of how much we still have to learn. Every discovery opens up new questions, new mysteries, and new possibilities. The tiny chance of a Pluto-Neptune collision may seem remote, but it captures the heart of what space exploration is all about. Embracing the unknown, daring to imagine, and recognizing that in the vastness of the cosmos, even the most stable paths can shift in ways we never expected. It's a call to keep watching, keep studying, and most importantly, keep wondering about what the universe has in store for us next.